Namaskar, I am KG Kapoor, safety professional and farmer scientist DRDO. In this session, we shall be discussing on safety in crane operations. In previous session, lecture 7, we have discussed types of cranes, tools and tackles used in crane operations, safety and use of tools and tackles, and finally, we have summarized regarding inspection of tools and tackles. In this session, lecture 8, we shall be elaborating on safety in crane operations. This is further divided in 5 sections: introduction, hazards of working with cranes, safety factors to be observed in crane operations, general guidelines for cranes, and the summary. 6 workers died and 25 others were injured because of the collision of 2 cranes at Samsung Heavy Industry shipyard in Jeoje, South Korea in May 2017. The company believed that the accident was the result of a miscommunication between crane drivers and the signal people. This again shows that there was inadequate training to the workers regarding communication during crane operations and signal to the people who are working in that vicinity. OSI's analysis of crane accidents identify the major causes of crane accident as boom or crane contact with energized power lines. Nearly 45% of the cases of accident are due to this reason. Under the log lifting device, overturned cranes, dropped loads, boom collapse, crushing by counterweight, outer rigger use, falls and rigger failures are some of the other reasons of accident during cranes operations. Objective of this session is that we should be able to understand regarding hazards of working with cranes, safety factors to be observed in crane operations, general guidelines for cranes, and in subsequent lecture 9 you will learn about the importance of safe loading in operations of crane and related aspect of cranes. Cranes are the typical example of mobile and transportable equipment used in the industry for lifting and shifting heavy loads. At the same time, cranes are quite prone to accident. Many times, accidents involving tower cranes have resulted in serious injuries and even death. Hence, while using cranes and other lifting equipments at work, one should be aware of the hazards and its management to ensure safety of the workman, equipment, and workplace. Working with cranes poses many hazards, and unsafe working practices can result in injuries, fatalities, and costly damage to buildings, equipment, and materials. So it's important to be aware of the main hazards and how to manage them. Some of the main hazards include falling loads. When working with overhead cranes, falling loads are one of the most common and most dangerous hazards. A falling load can result in serious injuries, fatalities, and significant structural damage to the building and property. It will lead to significant time and loss of money. Falling load from an overhead crane could be the result of operators' incompetency. Ensure the workmen are adequately trained so that they are able to carry out their roles and responsibility safely. Slipping of materials. Improper secured loads can result in slipping of material. Mechanical failure can be reduced if a competent person carries out routine inspections, maintenance, and repairs at scheduled intervals. Two blocking occurs when an uppermost hoist line component like load block, hook block touches the upper block, boom tip or similar component. When two blocking occurs, increased tension is placed on the line which can result in falling of loads or crane component. Electrical hazards is another significant crane hazards. There is always risk of a crane's hoist, line or boom touching energized power lines when moving materials nearby or underneath. Those directly touching the crane are the most likely to be electrocuted. Anything in the vicinity is also at risk. Therefore, pre-job planning for the work should be done, and that will help in prevention of such accidents. On April 7, 2021, recently Fort Lauderdale, Florida in USA, a serious accident has happened wherein a crane that touched a live power line caused an electrical explosion which landed a worker in hospitals and injured another worker who is still in serious condition. These power lines may be up to the as high. These power lines may be as high as 138,000 volts. Crane overloading is another hazard of working with cranes. Mostly crane structural failure are the result of overloading a crane. Exceeding a crane's operational capacity may subject it to structural stresses and crane irreversible damage. Whatever deformation is caused due to overloading cannot be repaired. Let's discuss some of the crane overloading reasons. Sudden swinging of heavy loads at a height can topple the crane altogether and cause serious damage to life and properties, and dropping of heavy loads from a height can also cause damage. Electric overhead traction cranes, normally we call EOT cranes, are mostly used in shop floors. Loading a crane with unknown weight to be lifted and moved, cranes likely to be overloaded. Such practices often lead to disaster. And where from these unknown weights are coming? At shop floor, several assemblies are being carried out. So many fabrications are there, and the weight is not measured. It is just an approximation of the weight, and that may result in overloading of the cranes, and that will cause a fatal accident. The tendency to manage with the available resources at the site leads to overloading of cranes, often with fatal consequences. One may follow the crane's rated load while loading what may find the hanging hook to be underrated, and that may take the risk which may soon turn into a disaster. Use of defective components to manage things in any possible way, often ignoring the safety rules, is also cause of overloading. It is responsibility of a safety engineer to change such habits and provide the right resources. A defective component in a crane, like a worn out tire or a badly welded joint in the lifting system, can be dangerous. Loads are always meant to be lifted vertically by cranes, but to accommodate working conditions, operators sometimes drag or side pulls the loads. When the loads finally leaves the ground, it can swing and cause a lot of damage to life and property, including toppling of the crane itself. Not paying enough attention to the loading chart provided on the body of the cranes is another hazard of working with cranes. Cranes have very clear loading chart and instructions fixed to the body of the crane in a visible location where it is least likely to be damaged. One needs to pay enough attention and study the chart before loading the crane. Loading charts shall be discussed in successive parts. Safety factors in the crane operations to be adopted. when working with cranes, there will always be hazards, and risk can be minimized by taking appropriate precautions while understanding all the operations safely. To carry out your crane operations safely, you should appropriately train all the employees. You should also ensure preventive maintenance as per schedule. Employer has a legal responsibility to provide appropriate health and safety training to all employees so that they become competent for their jobs. This will increase workplace safety, satisfaction and profit, and reduces the chances of injury, fatalities, accident and sickness, absence, machine downtime and repair cost. It's important to know the load weight and how that is affected by the conditions of the job site. The crane's load chart can help in determining whether the lift will be safe or not. The allowable load will depend on whether the tires of the outer riggers are being used with other factors. For example, asphalt may seem to be stable surface, but on a warm day it may become very flexible. Even concrete may not provide enough strength if there is a void beneath it. From a load chart in the right hand side figure, we will explain one example of our 30-ton crane. This crane will lift 60,000 pounds at 10 feet from the center pin of the crane. Based on the level surface and no wind and outer gear fully extended. At 25 feet from the center pin with the 80 feet boom, the capacity of is only 14,950, or roughly you can say 15,000 pounds. At 20 feet from the center pin, the capacity is further reduced to only 4,800 pounds. Therefore, we should clearly see from the chart whether the load is being lifted or being moved by the crane is safe or not. This will avoid the overloading of the crane. This is one of the chart which is available on the cranes, which everybody should be able to read. If you see in the red color mark that as farther we go, the lesser will be the capacity of lifting of the crane. If we go closer to the pin, then capacity the load lifting capacity of the crane will be increasing. Therefore, we should see from the chart what will be the load to be lifted be safer at a particular distance of the beam, at a particular angle of the boom. We should always study the load chart of the crane before planning the job. We should be ensuring that the load being lifted is within the safe working load of the crane at a particular distance and at a particular angle of the boom. This, you will see in the figure that closer to the pin, the boom capacity of lifting the load is more, and if it is as soon as the we are going further, then capacity is going to reduce. And this safe working load also depends on the angle of the boom. Therefore, we should use this chart in combination of the distance from the pin of the load being lifted and the angle of the boom where load is being to be attached. Safety factors in crane operations. For example, swing radius of a crane is the distance from the hanging point to the farthest edge of the mobile crane. It is this distance at least that the mobile must be hung from a wall or other object to that the mobile can rotate freely. The counterweight and boom travel within a specific arc is also called the swing radius. It is important to ensure that the area within that radius is barricaded off and to establish a control zone for those authorized to work in the immediate area. We should not allow the unauthorized persons or persons not required for that particular task. Therefore, we should religiously control the man limit in such areas so that we can reduce the accidents. It prevents personnel from being struck or crushed by the crane. The barricade must include the maximum swing radius of the counterweight which is past the main body of the crane. We should also check the area every day to ensure that there are no objects that the boom may fall with such as power lines. If such obstacles exist, one needs to ensure that the operators and other workmen are aware of the plan for avoiding them. We should use the crane properly. Cranes are engineered for vertical lifting. That doesn't stop some crews from trying to use them for side loading or other improper activities. Using a crane to drag something across the ground or from under the obstacles puts extreme stress on the boom, the turntable and all the structure's members. It could potentially weaken key components and lead to their failure. Communication or stay in touch is another factor we should pay proper attention. Whether one uses radios, air horns or hand signals, there need to be clear communication between the operator and the workman. That's especially critical when a crane is making a lift in which the operator cannot see the load, such as when air handling equipment is being delivered through an opening on another side of the structure. One should not assume that everyone will know how instructions will be communicated. One should build specific guidelines and make sure that everyone on the side knows exactly what each signal means. Avoid man baskets. Sometimes the easiest way to put employees where they are needed is to man basket to the work area. However, that approach creates hazards that must be tested and addressed before work begins, such as providing proper fall protection, verifying basket capacity and checking that the basket is properly attached. Before using a man basket, consider whether an articulating boom lift or a scissor lift might provide a safer alternative. Start with a plan. Each lift is different from another, and it's important to review load weight capacities, the integrity of the equipment, the possible effect of wind and other factors. The operator, riggers and other workmen involved with the lift should be part of the planning process. One must ensure that employees know they must not stand under loads and ensure that operators never lift a load over an employee. One must never stand under a crane or have a load lifted over oneself. Know, understand and comply with the lifting operation and lifting equipment regulations. That requires taglines on loads, capacity limit, ground stability and similar factors. Following rules and awareness training will protect everyone involved. Carry out routine maintenance and repairs of all on-site equipment as scheduled intervals as per legal obligations. The concerned authorities in government issue a fitness certificate to each crane in operation once a year. It is grossly illegal to operate any crane without this fitness certificate. Checking the operating functions daily is another important safety factor. The crane should be checked. The operating functions daily to ensure that everything is working properly. It's important to check the operating functions daily to ensure that everything is working properly and that there are no defects or cracks in the support chambers. Overload cranes used in heavy industrial application such as steel making need to be inspected even more carefully. Many of these cranes spend decades working in extreme environments such as melt shops. That constant exposure to intense heat and temperature swing can cause the beam and other structure members to become brittle and lose strength or even fail. Ensure a supervisor is present on site at all times when cranes are in operations. Make employees aware of and strictly enforce loading and lifting limits. Ensure clear warning signals are displayed on site when needed. One must display the relevant hazard signs as shown on the right side figures in all the danger zones on site to warn your employees of the potential hazards. All the employees must know and understand all the warning signs so that they are aware of when they are entering a danger zone. Select appropriate PPE for all employees. Ensure that employees wear appropriate foot, head and eye protections along with any other PPE that has been identified during the risk assessment. Single crane multiple winch lift is a complex operation. Some single cranes are designed to lift a load using both the main and auxiliary winches. Single crane multiple winch lift can be undertaken on these cranes in accordance with the manufacturer's instructions. This can occur, for example, to rotate a prefabricated concrete panel into its vertical position from a horizontal storage or a position suitable for transportation by using two hoist ropes. Even though the concrete panel will be suspended by two hoist ropes, each rope usually needs to be support more than 50% of the load during the rotation and one rope will have to support the full weight. Therefore, unless each hoist is capable of supporting the full load, it is important to use the main hoist to support the full load. The actual load to be carried out by each winch and rope should be calculated and documented by a competent person, such as an engineer, before the lift commences. Where a single crane is used for medial rotation, one should use a crane designed and manufactured for simultaneous multi-winch used. Follow the crane manufacturer instructions. If needed, reconfigure the crane before it can be used in the way. Make sure the main winch and auxiliary winch drives are independent. You should not exceed the rigging maximum design fleet angle. Rotate as near as possible in line with the panel of the boom to prevent side loading and sheaves. Monitor the load on the main auxiliary winch separately and simultaneously to avoid overloading either a rope and to make sure the combined load of both the ropes does not exceed rated capacity, not exceed the included angle between the main hoist rope and auxiliary rope by more than 10 degrees are determined by the manufacturer or a competent person unless otherwise specified by the manufacturer, and rotate with enough clearance to make sure the load does not strike the ground, crane or other objects. A competent person should confirm the minimum required capacity of each hoist rope, that is, the maximum load placed on each rope during the rotation. Sometimes the auxiliary winch line passes over the rooster sheaves, the sheaves mounted on a side boom extension. Do not overload the rooster sheave, as some are not rated for the full line pull or the auxiliary which and are not suitable for the purpose. Rooster sheaves and the associated rigging on the boom head should be designed and certified by a competent person. Multiple crane lift. Lifting a load with 2 or more cranes requires detailed planning and supervision because the movement of the load between the cranes may create extra loading on the cranes, the load and the lifting gears. The design capacity of a crane will not be maximum rated capacity, but the derated capacity relevant to the multi-crane lift to be carried out. The cranes to be used in the lift will need to be derated. No load should be lifted simultaneously by more than one crane unless a single crane lift is not practical and the multiple crane method is required. In such method, you should ensure the load placed on each crane does not exceed its derated design capacity. Where multi-crane lifts are carried out, a documented lift plan and the procedure should be prepared by the competent person and it should be followed. Where it is necessary to lift a load using more than one crane, the person in control of the lift must hold at least an intermediate rigging high risk work license. This is very important. Everybody cannot work on such cranes or multi-crane lifting. They should have a license for the rigging high risk work. The crane used for demolition. Cranes should not be used for demolition or for wrecking bulwark. If a crane is used for demolition, bulwark should be thoroughly inspected and verified by a competent person after the work is complete as being in a satisfactory condition before it is used for general lifting. The results of the inspection must be recorded in the crane service logbook. Cranes used for demolition work must be fitted with suitable operator protective devices, for example, FOPs, to protect the crane operator. The hoist rope should be prevented from leaving the boom point sheave. Other ropes should not be fixed directly to the demolition ball. A length of chain should be used to join the hoist rope to the demolition ball. The chain should be at least 16 mm and at least 2 meters in length. Now, let us discuss the general guidelines for cranes that will prevent the accidents. A crane may not be in use if it is unattended, parked or stored. You must make sure, so far as is reasonably practicable, a crane that is not in use is left in a state that does not create a risk to the health or safety of a person. Except in emergency, due to fire or other threatening regions, the crane operator should never leave the crane cabin or control while a load is suspended from the crane. A crane should not be left unattended unless loads are removed from the hook or lifting device. The hook has been secured or raised to a position where it is clear of outer operations. The crane is properly stopped. Powered movements have been disabled and the keys are removed or the starting device locked out. When leaving a mobile crane unattended for a period of time, ensure the crane's boom is retracted and lowered as far as possible. Where there is no risk of a tower crane boom contacting outer structures, the crane should be left to weather vane when unattended according to crane manufacturer's instructions. If a crane is to be stored, it should be prepared to be left unattended and the manufacturer's storage instructions should be followed. Remote control equipment isolated, the power supply and controls isolated and locked off, storm anchors applied if fitted and doors and windows locked to prevent unauthorized access. There are certain guidelines for decommissioning and dismantling a crane after the life of crane is over. A crane must be decommissioned or dismounted by a competent person and inspection must be undertaken during the process. A crane should be decommissioned and dismantled according to the manufacturer's instructions only. Now we will summarize so far what we have discussed. In this session, we have discussed how the accident can take place to the crane, hazards of working with cranes, and factors to be observed for safe operation of the cranes as well as general guidelines for the cranes. And at the end we have discussed the decommissioning and dismantling of the crane. Thanks for learning safety skills and contact for any question in future.